Ever pondered the significance of valves in a chemical plant? Their role is paramount, serving as the silent workhorses, controlling the flow of fluids, gases, and other substances within the system. The smooth operation of a chemical plant hinges on these components as they orchestrate processes, ensure safety, and uphold the plant's overall efficiency. First off, we have gate valves. Distinguished by their simple design, these valves employ a gate that either rises or lowers to regulate flow. They come in handy when a straight-line flow with minimal restriction is needed. To maintain a gate valve, conduct regular visual inspections to hunt for leaks around the valve body and stem. Lubricate the stem for smooth operation, and periodically disassemble the valve to check the gate and seat for any signs of erosion, corrosion, or wear. And remember, always verify the proper alignment of the gate during reassembly. Next in line are the ball valves. These versatile valves use a rotating ball to manage flow and are often the go-to choice for quick shut-off applications. To keep a ball valve in top shape, inspect the ball and seats for wear or damage, check the stem and seals for leaks, lubricate the stem and handle, and periodically disassemble it for a thorough inspection of all components. Then we have the butterfly valves. These lightweight valves use a disc that rotates around a shaft to control flow, making them ideal for large diameter applications. To maintain a butterfly valve, inspect the disc, seat, and stem for wear, lubricate the stem, ensure the disc is free from debris, check for leaks, and verify that the disc is correctly aligned during operation. On to check valves. These one-way valves allow flow in one direction only, effectively preventing backflow. For maintenance, inspect the valve seat and disc for signs of wear, check for any debris that might hinder the valve's closing, ensure proper spring tension or counterweight for swing-type check valves, and verify the valve's correct operation and sealing. Control valves come next. These critical valves regulate flow based on signals from a control system, ensuring the maintenance of process parameters. Regular calibration of the control system is a must for accurate control. Inspect the valve body, trim, and actuator for signs of wear or damage, check for leaks in the packing and replace if necessary, and verify that the valve responds correctly to control signals. Pressure relief valves are up next. These valves protect equipment from overpressure by releasing excess fluid. Regular testing of the pressure relief valve is crucial to ensure it opens at the set pressure. Inspect the valve seat, disc, and spring for signs of wear. Verify the valve reseats properly after each test, and check for any corrosion or buildup that might affect valve performance. Finally, we have diaphragm valves. These valves use a flexible diaphragm to control flow and are often used where cross-contamination is a concern. To maintain a diaphragm valve, inspect the diaphragm for wear or damage, check the valve body for leaks, ensure the proper alignment and operation of the diaphragm, and lubricate moving parts as recommended by the manufacturer. Remember, regular maintenance of valves is the key to preventing unplanned downtime. Always adhere to the manufacturer's guidelines and industry standards for valve maintenance. So, there you have it. A brief tour of the vital types of valves in a chemical plant and how to keep them running at their best.